Thank you, John. So, thank you all for coming. Thank you for inviting me again. I did not invent cron, but I have an association as follows. It was part of the old AT&T Unix, and that advanced beyond the point where Berkeley Unix forked off. And their cron at AT&T had some stuff I liked, like sending you email if your job generated output. And I thought, what better way to learn the Unix system interface than to re-implement cron in Berkeley Unix using all of the modern features that were only then in AT&T Unix. I did this in the 80s as a recent high school dropout. You know, that's just me, a career of doing everything the hard way. But later, Linux came into existence, and then BSD forked several times, FreeBSD, NetBSD, and so on. And all of them, including Mac OS, are including the version of cron that I wrote in the 1980s. And I love that. But I did not choose the interface. The format of the cron table with those asterisks, I would never have done it that way, but I was trying to be compatible. And so do not blame me for how hard it all is to use. So I have a blue shirt, but I'm not a volunteer. I guess maybe I am, but not in the sense of being in that picture. On the shirt it says AWS. That is the organization I support. I am not actually part of the AWS subsidiary of Amazon. I am part of Amazon Corporate, and we are a team of some number of thousands of people dedicated to securing the AWS infrastructure and the customer workloads. So AWS, in a sense, is my customer. I don't report to the CEO there, but I care very much what he thinks. All right, so with those details out of the way, I'm here to talk to you about generative AI, of course, because that's the thing. And specifically how it can be used in security operations. Not just security operations, but security work in general. So a little bit about AI. The term was coined in 1957 or so at MIT. John McCarthy's team fooling around with stuff that became Lisp. They wanted to do something which we would call, in today's terminology, expert systems, but they called it artificial intelligence. I guess that made it easier to get grant funding. And it was fantastic work. If you ever have a chance to play with a Lisp machine from Symbolics, for example, it's cool. Man, there's a lot of lost excellence from that era. In any case, as the decades wore on and we got smaller transistors and eventually integrated those transistors, AI changed what it meant. There was some other shining city on the horizon that people wanted to march toward and called it artificial intelligence. And so every decade we have done something that we called AI. What's different now is that our friends, our family, the non-tech people in our lives are using the term AI. They've now heard about it. And this is the first time we have been doing something which, for this decade, is what AI means, that the rest of the world can actually see. That's the breakthrough. Now, the technology that we are using to do that which we call AI, generally speaking, is machine learning, reinforcement learning, neural networks, and there's a lot of back propagation. And those of us who have been using those earlier technologies but weren't calling them AI were a little bit confused when the hype machine in Silicon Valley spun up and said, hey, AI, it's cool, you need this. As they had done for digital currency and many other things in the past. The Silicon Valley hype machine always sounds the same. You can't tell from what it sounds like whether it's going to be a real thing or not. But we were a little confused because, we've been doing that. We just didn't call it that. So what's new here? Now, there are some things that are new, and I'll tell you a little bit about those. But this whole idea of fuzzy logic, where you don't want to develop your program code in an imperative way, where you have to know in advance what the possibilities are, that's been going on for a while. In fact, we could argue that the Alta Vista search engine and the Google search engine of that era were a form of this. Because searching when all you can do is look for substrings, tell me a web page, tell me all the web pages that use these 3 words, wasn't useful. And so they were doing a lot of fancy stuff even back in, I guess, the late 90s, early 2000s, which by today's standard of terminology, we would say was AI-based. Now, the problem with search is that you have to know what you're looking for. When we go to some kind of a browser-based tool and say, I need to find a thing, we have to know something about that thing. We have to have a picture in our heads that we're trying to express. And then we got to get the machine to infer what that picture is and give us its best guess. So search is also a little bit imperative. And imperative logic got us this far, but it won't get us to autonomous driving, for example, where you have to have program code that says if there is a stop sign, then you must slow down and come to a full and complete stop. I mean, you could do it that way, but you would always leave something out. And so what we're going to do instead is come up with a machine representable pattern of both driving rules, driving norms, sort of reactive norms. Gee, if somebody tries to T-bone you, this is what you should do. Swerve this way, not that way. I'm not going to be talking about the problem of do you kill these people or kill those people. I'm just saying that in general, we will not get to that level of futuristic technology in the lives of all of us using imperative logic, where we're sitting there in front of a browser, typing a lot of if statements. We're going to have to do it in a fuzzier way. And that's kind of what machine learning, neural networks, AI, generative AI is doing for us. So as to security, I see the world through the security lens. And I am in an organization full of people like that. And so, if you meet too many of us at once, you might get overwhelmed with how broken we all seem. Because everything you tell us, we're going to be thinking 3 things. Every new thing, every new technology, every new hope, dream, or fear, anything that might happen, we're going to be wondering 3 things. How do I defend it if we start employing this technology? How do I defend us while adopting that? How can I use it to defend other parts of the organization? And how will I be attacked by people who have access to this technology? So yes, I understand it's going to change the world. Maybe we'll get autonomous driving and all kinds of other stuff, flying cars. And that probably will not be driven by security people because they'll always be worried about how it's going to be misused. And we have a place in the world, I think. It's important to be thinking those thoughts. I'm glad that not everyone does. But that is security. And so when you take the question of generative AI, how do I secure that? You could look at it as, how do I defend against it? People who have it. You could think about, how do I use it to defend things? You could think about it as, how will I defend us once we're using that? It is the second of those 3 items. How do I use it to defend us? That is my topic today. So generative AI differs from AI proper in that it is meant to be, I don't want to say inductive, but it is meant to be able to generate new output that sounds a lot like its training input, or looks a lot like, or approximates in some way the training input. And one of the great things about that, we call it the uncanny valley, where you get into a conversation with a chatbot and you would almost believe that it is a human. Maybe a human with a lot of tech biases and a human without much real world experience, but it just sounds a little bit like us, and that's because it's trained on what we have said and written. There's no current thing that I would refer to as reasoning. A lot of companies are chasing artificial general intelligence, AGI, and there's arguments about what that could mean. But in the sense of us in this room, it would mean that it would learn the way we can learn. Maybe not exactly the way our brains work, but it could learn what we can learn. We've spent decades growing up learning to tie our shoes and all the other stuff that it took to get to this room. We expect that there's a lengthy period of learning before any of this, any given instance of AGI is going to be useful. And then we presume that AGI is going to be able to act like us, learn new things, integrate new knowledge like we do. We're a long way from that, and there will be some very fascinating security issues there because we learned in the context of being alive and having consciousness and having judgment. This technology is going to evolve in a different context than we did. And so we're not totally sure, I'm not totally sure how we can make sure that it wants what we want. And in particular, if somebody ever does create some sci-fi-like creature that is made only of transistors but is conscious and has a value system, it's difficult to imagine the basis under which we will enslave it and tell it that it can only do what we want, because it is our consciousness and judgment and humanity and so forth that we use to say that you can't enslave us, that we cannot enslave each other. So a lot of fascinating things will come there, but that's where we get to the muddy part, the overhyped part, because not everything that is being offered to us under the label of generative AI is generative AI. With a large language model and all of the transformer-based backpropagation. Those are the things, those technologies are the reason AI is on the lips of every citizen now, rather than just a technology curiosity. But not everything that we do actually uses all that stuff. I'm going to give you some examples. But just be aware that when you hear somebody talk about generative AI, it may be that they're still doing machine learning. They just have been told they have to call it generative AI now. Not all AI is the same. Security lived, observable, measurable security can be predicted. In other words, if you know what the operating conditions are, and by the way, we have the ability to create operating conditions, which we do every day of our lives. You pay your rent so that you can have this house for another month or whatever it is. We're always doing things that affect our operating conditions. But if you want to predict how secure your outcomes will be, there are elements of our operating conditions that are very reliable predictors. To me, one of the most glaring, overlooked predictors of your security experience has to do with the understanding gap, right? We who are trying to defend infrastructure, digital infrastructure, networks, servers, applications, storage, customer workloads, if we're trying to secure that, we have to understand it a little bit. You're not going to just treat it like a black box and build a fence around it. I know that temptation is real, but that won't work. What we're going to do is study it to some degree and understand enough about it that we can be sure that its vulnerabilities are known, or if some become known, that we will be one of the people who knows them. And you got to treat this as this big, complicated thing. Every variable in a program is a state variable in control theory. Every predicate in a program is a state transition function in control theory. And if you take the total number of state variables and the total number of state transition functions, that is the totality of what you're trying to defend, that gives you some sense of how much there is that could potentially be understood. Nobody's going to get to 100% of that. Raise your hand if you knew that your AMD EPYC chip has a 386 processor in one corner of every chiplet running an out-of-date version of Linux, and that is the only way to boot, because you have to have a 32-bit Linux machine inside the EPYC core in order to even get the EPYC core to have microcode. Did you know you had that? Did you know that that is connected to one of the Ethernet ports on the backside of your servers, and that it is possible for that thing to send and receive packets that your operating system will never know about? Did you know that you should probably not use that Ethernet port for anything? You probably didn't. And that's the tip of the iceberg. There is so much that we do not understand that is inside the complexity blob of that which we must defend, that it predicts bad outcomes. And if you look at our press, you look into sort of how our society is doing now that it is connected to the internet, you'll see that we lose pretty often. And it is that complexity to understanding gap that predicts how often we will lose. So one way to close a gap is to understand more. But there are limits to that. In particular, I'm in the business of securing infrastructure, but most companies who have infrastructure are in the business of trying to create value for their customers. And they need digital infrastructure in order to do that, but that is not where their revenue is going to come from. In fact, defense is a cost item to most businesses, not a revenue item as it would be to me. And so there's a limit to how much of that cost you can endure before you become unsustainable as a business, whereas there is no limit to how much complexity you can adopt. So increasing your understanding level is good, but you could also decrease your complexity level. You could say, this old Spark system from the 2000s can't be patched. The company who made it is now Oracle. They don't know about it. They don't care about it. I have no idea how many things it might be vulnerable to. It is part of the system that runs our factory floor, but the best thing for the business is to unplug it next Friday and live without it, rather than continue to just deal with this blob of completely 0% understood technology that is at the heart of our business. That's a hard decision. But those are the types of decisions that you make. Remember about security that all war, including a Cold War like this one, is about economics. You are trying to defend at a lower cost than your attacker. And in that case, they'll have to go elsewhere and find a different victim. Or you're trying to attack, not you, but somebody's trying to attack at a lower cost than the defender, in which case they can commit enough ransomware that their revenues will be astounding. So if it's about economics, then how much it costs you to understand things, or how much it costs you when you don't understand it, are the types of things that your CFO is going to be thinking about. And it's the type of thing that we as technologists need to be able to inform the CFO about. Okay, so that's the backdrop. I burned some daylight here, but we have time. We at AWS Security are finding ways to use modern AI, which certainly includes the ability to build models and do inference using models, retrieval augmented generation. You know, we use all of that stuff, but we're using it in a very security-specific way. Now, famously, I believe ChatGPT has a random number generator built into its inference model so that it will not give the exact word-for-word answer every time to every questioner if the same question is asked, the prompt rather. And that's because that would be boring. That would get you out of the uncanny valley. A human wouldn't do that. I mean, some of us do, but. So that randomness means that it's non-deterministic by design. Security people hate anything that is non-deterministic. If we give the same input, we want the same output, and if that doesn't happen, we raise a flag or open a ticket. So we turn all of that off, first and foremost. If you're going to use use AI in security, you will not be letting it try to sound human. You want to know what it says based on what you say, but it really has to be as boring as possible, because it is the content of what is said that matters, and if the content is changing, you can't trust it. Early example of something we did was shift change support. We have a security operations center. It's virtual, it follows the sun. So, we hand off to Sydney and Melbourne at some point at the close of our day, but at the opening of their day, and then they hand it off to Europe, and Europe hands it back to America. And as long as the Earth keeps spinning, we will keep doing it that way. The trouble is that the incoming shift, they just got to work. They're still drinking their coffee. They don't know what you have been doing in your shift, and they have to know, because you're about to hand them a pile of tickets. These are the things that are still open. And I guess if the new shift wants to look and say, well, what came in that you actually dealt with and closed, if they want to look, they can. But the thing they have to know is what's still in progress. And until Bedrock and SageMaker and these modern textual engines that can do word prediction based on stochastics, we didn't have a way to make that more efficient. But somebody whose problem this was and was feeling the pain from it saw the new technology, said, I know how to use this. And so now, certainly the incoming shift in the rotating Security Operations Center, the virtual SOC, they still get all the tickets because they are just there. You press that particular button and you see the list of what's currently troubling somebody that is security related. But what they also get at the beginning of their shift is an AI-generated summary of every one of those tickets, which means, I don't want to, we generally don't talk about numbers, but let's say that there are 25 the tickets still in progress from the previous shift, and there could be 2, there could be 200. I'm just going to say, what if there were 25? If every member of the incoming shift has to read every one of those tickets before they can be useful, that's a huge overhead. That is cost in our system, because while they are trying to bring themselves up to speed, they will not actually be working any tickets. So we needed to make that more efficient. And if they can just get let's say a 2 or 3 page document that has one very pithy paragraph about each open ticket, that is based on some LLM looking at the content of that ticket and generating a summary, that does not tell them what they're going to need to do that shift, but it tells them which ticket they need to read first. That is huge, because human effort, mind share, the ability to get trained people who are trusted to sit at that VSOC is hard. And in order that we be a sustainable business, we can't just hire an infinite number of them. And especially if the more you hire, the more cost you have of them coming up to speed at the front of that shift. So this turned out to be a gigantic win for us. And I know it doesn't sound like a James Bond movie with people running across rooftops shooting at each other, which is, I guess, how we sometimes are trained by Hollywood to think about security. It turns out a lot of security work is very boring. It's just people reading and writing responses and so forth. It looks a lot like software development, in fact, if you're watching somebody who's doing it. So our mission parameter, our mission, as I said, is to secure the AWS infrastructure and AWS customer workloads. One of our parameters is that whenever we decide what we are going to do next, not the VSOC, but the AWS security organization in general, our guiding light is either to raise the security bar or become more efficient so that we can take some amount of budget, some number of people who used to be doing things the hard way, and automate those so that the people who've been doing them can start working on something else. That would be an efficiency gain. But this was both, because it meant that incoming virtual SOC teams knew more about what they needed to be doing, which made them better at their job, which made us be able to address the right tickets first and close the important ones first. And it allowed some people who used to do stuff the hard way by hand to now benefit from operation. And of course, if we can achieve both mission parameters at once, that's a pure win. Here's another example. Triage, right? These tickets all come from somewhere. What if, let's say they come in with a severity level that is inappropriate, right? It is low when it should be high, or it is high when it should be low. Well, if it's high when it should be low, then it's going to pop up first, and some human operator is going to have to look at it, at which point they may say, this is high when it should be low, and then that human operator will downgrade that ticket and indicate in the log why they did it. If it is low when it should be high, then it's like, oh my goodness, I didn't get to this because it was marked low, should have been marked high. There's some service team somewhere who needed to get paged out of bed so that they could look at this problem. And now it's been hours, and it should have been minutes. So these are problems. And I won't call them miscategorizations. I'll just say that before something is triaged, you don't know if it has the right severity level. But it turns out that things that should be high all look like they should be high. They use certain keywords, they refer to certain URLs, they refer to certain other tickets. And it turns out that just as summarizing the tickets at shift change can be done by LLM, by generative AI, so also can be that initial triage. And again, we're doing it, it's working, it is allowing us to be more efficient, it is allowing us to get to better outcomes sooner. Here's an odd one. There is, of course, an industry full of CVEs. These are vulnerability announcements from somebody who developed some software, and then a bug was found, and so now there's a patch, or there's going to be a patch. I've maintained Bind, which is DNS software that came with BSD, from around 1990 until around 2003. And I also had my own version of SendMail for a while when Eric Allman was working for Britton Lee Software. And then there's cron, right? I've written a bunch of open source software. I've also maintained a bunch of it. And it turns out that I hold a record that isn't in the bio that you were told today. Because if you know who was responsible for each bug that was blamed on SendMail or FTPD or whatever, if you know who wrote the code, or in my case often who accepted the code as a patch from someone else, then it turns out that I am responsible for more CVEs than any other author. Eric Allman gets blamed for stuff I did, for example. But CVEs are a huge thing, and there are a half dozen a day on a good day, and some of them are very important. Often there will be an embargo period where you can't give the details because you don't want zero-day access from the bad guys. So you have to write these CVEs in a very cryptic way where you somehow incentivize your audience to care about what it is without you telling them why they should care. I remember a patch that I needed to make in Bind, 1999 or so, but the bug came in during the Christmas holiday, and one of the largest users of Bind version 8 at that time was the US Air Force. And they don't work during Christmas break. They're not there, people that we would like to talk to. So we had to put out a patch that would not indicate what the problem was. And I dutifully refactored 1,000 lines of code across the system, and I think improved it. I don't think we created any new security vulns, although if you wanted to, this is how you'd do it. So that anybody looking at it would have to spend a lot of time trying to figure out what is the actual bug here. Crazy times, but you know, we had to build the internet without having GitHub yet, because we needed an internet to have GitHub. So there's a lot, just all kinds of stuff we did that was crazy in those days. Anyway, so the CVE flow, it never stops. And when you see one, you right now have to use human judgment to look at it and say, are we vulnerable? Is it describing something that we are actually running? Is it describing a version of it or a range of version numbers that we are actually running? Are we not necessarily running it, but was it a build dependency of something we are running so that we now have a static copy of a shared library that isn't on our inventory of things that we know we're running because it's a dependency? Do we have to rebuild what that was? You know, that's a problem. And there's a software bill of materials industry now out there designed to help get access to that problem. But the thing that I said that is most significant is that it requires human effort, human brain power, human judgment to look at these CVEs and decide, is this important enough that we should set the corporate person's hair on fire and do nothing but this until it's fixed? Again, generative AI to the rescue, because CVEs that need to be looked at can be, if you have fuzzy logic rather than imperative logic, can be kind of inferred. You can decide what the priorities should be. Eventually, the CERT people of the world allowed other CVE numbering authorities, so-called CNAs, to exist besides just the CERTs. And any number of organizations, including Amazon, have become sources of CERT advisories. In other words, if we discover a security problem in our stuff, we can publish a CERT and we can give it a CVE ID number. And that CVE ID number will probably include something about us to tell you where it came from, but nevertheless, we are a numbering authority. So is the Linux kernel team. And the Linux kernel team decided, we don't want people to use human judgment. If we say it's a CVE, we want everybody to patch it. And so the CVE score that comes from the Linux kernel CNA is always 10.0. The highest possible score. Okay, that's just not realistic. You think about Amazon Linux or any Linux, there's just no way that we are going to rebuild and repatch all of the systems running that every hour, which is what it would be. The laws of physics are between us and that horizon. So it turns out that if you can actually puzzle through it and look at it and decide if it is a code path that you might exercise, if it is a kernel module that you are actually using and so on, then you can reconstitute the effective score to say, regardless of whether and it's the same story as before, if the author of this CERT advisory ranked it either too high or too low by our local standards, then we can say that the effective score, which should drive our priority schemes, will be different from the offered score. And again, imperative logic isn't going to get you there. You're going to have to be able to look at a large corpus of training data and see effectively, if it starts like this, it usually ends like that. And unfortunately, this creates a bit of that black box I told you earlier that we didn't have and didn't want to have. Because once you're using this type of what I'm calling here fuzzy logic, explainability gets a little tough. Why did you come to this conclusion? Well, I looked into the blob and I surfed the numbers and I went in over here and I came out over there. So guess what? That means we're getting more results by adding more complexity of a particular complexity type that we cannot understand. I think I explained earlier that as the understanding gap increases, the quality of your security outcomes usually reduces. So one of the things I personally am working on is how to inspect and validate that black box, how to make sure that we have explainability, not just when we need it, but all the time, so that we can sort of use a bunch of AI over here to watch a bunch of AI over there. Yeah, there is the question, who watches that AI? I'm not going to get into that. I'm just saying that we're not going to be using human judgment to validate the correctness of the contents of all of these models and of the things that go through them. We're going to be, we're going to do something. There's going to be some kind of automation that allows us to get the understanding gap back under control, instead of saying every time we use AI somewhere, that's just a part that we will no longer try to understand. I can't do it. I can't go there. So here is another example. When we want to generate a CVE about something we've done, it could be Amazon Linux, it could be, you know, open source software that we're responsible for, whatever. If it's stuff that we've done and we want to publish a cert advisory for, and it's not exactly what they're called when they come from us, but if we want to publish one of those, we have to decide how to score it. And right now we're using human judgment to decide how to score it. And it turns out that if you can turn some generative AI loose on that, then you can sort of come up with an explainable reason for why the score is this. These are the things that we found, they add up to this number. And if, yeah, you're not going to let that go directly out into the broadcast, but if you need human judgment to validate what the machine has decided to recommend, that's very little human effort. If you have to do all the work using human brain power, you're going to have to hire more people than you can afford to do and still be cost competitive in the market. So I've given you some examples that are not sexy, that are either meant to improve your security outcomes without drastically increasing your costs, or to reduce your costs and keep the security bar where it is, but get there more efficiently. If you do that well enough, then the fact that security work on the internet is a form of Cold War, and war is about economics, and the cost of defense relative to the cost of offense is kind of determinative of your fate. And it turns out that doing this well over and over again in bigger and bigger ways is the best strategy. So it's 10:30, and although I love the sound of my own voice, I go out into the field a lot. You know, my job as a distinguished engineer and vice president sounds like I should be sitting at a desk writing white papers, and perhaps I should, but I also have a huge affinity for customers from 3 decades of startup work before I came here. So I go out into the world a lot and meet with a lot of chief information security officers, listen to their pain points. Sometimes I can offer them a solution. Did you know we had this thing? Sometimes they get angry that no one told them before me that we had this thing. But I'm here to listen. I want to hear your voices. I want somebody to raise their hand and say, I disagree completely with what you said about thing. Help me out here. No? Ah, a hand. Wait a minute, your microphone is coming.
Oh, I heard this at reInvent, but could you talk about how AWS is protecting when you submit your data to the model? You don't want the model to then, use your sensitive data and all that protection that goes into that. Could you speak to that?
I can, and that's an example of a type of security that I enumerated as what I'm not going to talk about today, but I'm happy to talk about it since we have minutes. And that is, how do you secure it once you're using it? How do you secure yourself once you've added that to your complexity mix? So when I saw the ChatGPT announcement a couple of years ago now, I recognized immediately that I was not going to be testing it because they would be a non-contracted party, and I would have no way of verifying that they followed the privacy policy. I would have no recourse if they didn't, and that the data that they collected from the world by announcing, hey, here's this cool chatbot thing, it's free, you should try it, that data was their real value play, that giving stuff away was not going to help them. They needed to use this as a demo to generate commercial interest, but they also needed our prompts to figure out what the next generation of their system should do. And it's certainly possible that they also sold it to the advertising networks of the world to optimize our web experience. So I just didn't do it until Amazon came out with a chatbot, because I know our privacy policy and I know whether we follow it because I'm one of the people who make sure we do. I was a little worried about how much data went into it until some company, I don't know, Japanese electronics company, got their name in the papers because some engineer had uploaded a bunch of proprietary source code to ChatGPT, and it turned out that that became model training so that if you could ask the right question, you could get access to that source code. We never do that. It is our policy that every AWS customer is in control of where their data resides and who will have access to it and how it will be used. So we never train anything that is not yours or specific to you using anything that you have done. So when DeepSeek came out, similar concern. Do we really all want to send that much personal data and metadata and prompts to an economy on the other side of the world, has different laws than we do? I didn't until we had it in Bedrock, in which case I felt perfectly free to go access it there, because before it can get into Amazon Bedrock, a bunch of people will have looked at it and made sure that it's not phoning home, and that when it can't phone home, it doesn't just die. I mean, there's no reason to release it if that's going to happen. So yeah, you need a technology supplier that you have a contract with, where you know the laws they operate under, and you have recourse against them if they don't do what their privacy policy says or if they injure you in some other way. And if you haven't got that, don't participate.
So how did they roll in DeepSeek? How did they roll in DeepSeek and manage that, the security there?
Oh, how did we?
Yeah, Amazon.
Oh yeah. Well,
Repeat your question again.
Didn't Amazon take in DeepSeek as a partner, and how did they roll in the security and manage all that?
I don't know about partnership one way or another. What you said could be true, I don't know. But since DeepSeek was offered as open source, we are one of the people who pulled over the source code, built it in our environment, and then containerized it to make sure that it was not going to phone home or otherwise leak any data either between our customers or out into the world. And so if you're using DeepSeek through us, then it's my opinion that your information is safe. If you're using DeepSeek without us, then you need to find some way to predict what your experience will be. Somebody has come up, I don't know if it was Docker or whatever, somebody's got a container that is DeepSeek that you can run on your laptop because it's fantastically powerful because it's so small. And that also has been containerized. But verify, then trust. I had a question over here. And then we're down to our final minutes here. It's 10:39. Do you want me off the stage at 10:45, 10:40? What is it? I'm going to go to 10:45 unless I get the hook. Next.
Thank you. I have been a Unix sysadmin, so you have been deeply admired and respect the kind of legend in this area, so really appreciate. And my question today is, with all the threat report, the top risk actually is human, through the human, like social engineering, phishing email, and also kind of a lot of costs increase go to help desk, try to change passwords, steal identity. So I want to hear your kind of advice in this area.
For the most part, in order to succeed in business, you don't build anything better than you have to. And I'm not pointing fingers, I'm not accusatory in this way, I'm just saying that if you invest more in your service infrastructure than will ever benefit your customer, that's possibly crazy. And as a result, we have a lot of security tools in the world, like CAPTCHA, or you got to attach a photograph of a receipt in order to submit an expense to an expense report, or you've got to get somebody on the phone and talk to them and hear their voice, or you've got to see them on the screen. Every one of these things is now under threat. Every security tool that we had can now be gamed using this fantastically powerful new technology. And this is, by the way, the third category of the three that I also said I wouldn't talk about, which is how do I secure myself against attackers who will use it? And the answer is, in general, go look at every assumption you have and maybe even do some red teaming, either internally using the people you have, buy that engineer an expensive dinner for his whole family if they can crack some aspect of your system, or hire somebody. But it turns out that what's going to hurt us here is that inhuman agents are going to be able to break through all of our protections against inhuman agents. And that is the era that we live in. And it's not that I'm not working in that area, I just knew I didn't have time to explore it with you today.
So GenAI models are prone to often security struggles such as false positives. In that,
Slower.
GenAI models are prone to security struggles with respect to false positives. So how does handle the situations in which the AWS handle the situation in which GenAI models be a more asset than a noise amplifier?
I'm sorry, I'm not understanding your question. Let me hop down there. Let's get
So GenAI models are prone to false positives. So how does AWS handle these protocols in such a way that they are not noise amplifiers?
The question is about something that is often called hallucinations. Since generative AI is statistic in nature, it can make mistakes. Since it is statistical in nature, it doesn't actually know the semantics of its training data or of your prompt. And in that environment, you can often achieve spectacularly wrong answers to what you thought of as a fairly simple question. And obviously, there's a lot of work going on. Every company who has AI-based technology in the marketplace understands that that's bad for business. We are all trying to improve it. Sometimes the improvements are done in the research area where somebody publishes a paper about it and then everybody benefits. I assume that there's also improvement going on that nobody writes about. It just makes one model better than another. So since that is a known risk of the technology and it is due to the fundamental design of the technology, we solve it with disclaimers. We just let you know if the answer is meaningful, if you're going to bet your life on it, please get a human expert to verify what we're telling you. I want a better answer, and I'm working for one. That's just, I'm telling you how it is now. Am I out of time?
Yeah, you can take questions.
Hi, Paul.
Offline now.
So what?
You can take questions offline.
Okay. Thank you all.